This is the new example, and this is kind of complex example. As you can see, it's going much more harder with each example. But don't worry, I'll teach you trick parts, easy things, and we will get it. So now the question is degree of freedom again. Let's write the formula: L minus lambda times L minus J minus 1 plus total 1 to the joints total Fi. So lambda is again 3 for two-dimensional. So now time to find out the number of links and number of joints. So I'm gonna start with ground as usual. I just wrote down for every ground 1. Our first link is the ground. So guys, there is another link is starting over here, and it's going like this. Oh, there is a new thing. What does this mean? If you will see like these symbols, also we have over here, also we have over here. It means, guys, this is a welded point. This rigid body and this rigid body are welded to each other, welded point. What does that mean? These are stick to each other, right? These are stick to each other. This is stick to this. This one is also stick to this. So you should think this, also this together. So this is our second link, which includes this whole link. All right, don't forget it. But we have a different rigid body over there, which is sliding in the second mechanism. So I'm gonna write down 3 for this rigid body. Also, I have another link which is connecting between the third and first, which is ground link. So this one is, we can write down here 4, right? Don't forget it. This one is completely second link. So there is again another link is starting over here. So this one is 5th link, but it includes also with this, also this rigid body, because this is also, these are also welded to each other, right? Okay, do we have another link in this mechanisms? Yes, we have. Look at this, guys. This link also is continuing at the background with this. This link can sliding in this channel. We have a channel over here in the ground, right? So this link can be sliding motion to the left side, to the right side. So it means there is another link. So I just wrote down there 6. Do I have another one? No, that's all, guys. So we have 6 links. Now time to find out the J, which means joints. Between the first and second link, what kind of joint do I have? Here we have typical R joint, right? Between the second and third link, what kind of motion do I have? Look at this, guys. Third rigid body, third link can be make a sliding motion in the second link, right? So we have between this point. So don't forget it, guys. We are now analyzing the kinematics. Kinematic means we are just investigating at that moment. So at this moment, second and third link are connected to each other at this point. After 1 second, maybe this rigid body will going to this side, but we don't care it in the kinematics. In kinematics, we just care at that moment. So at this moment, between the second and third link has a prismatic joint at this moment. But also at this moment, we have a R joint between the third and fourth link, guys. So we have two different joints at the same point. All right, prismatic joint for the second link between the second and third link, revolute joint between the third and fourth link. So this is the one of the trick part, guys. All right. So do I have, okay, we have also another R joint over here between the first link and fourth link, as you can see. What about between this is the second link, guys, right? This one is the whole second link. So between the second link and fifth link, we have here again R joint. What else, guys? Between the fifth link and sixth link. So here, what kind of joint do I have? This rigid body can make a sliding motion to the upwards to the downwards, or upwards or downwards to the upwards, right? So it is sliding also. So there is also, we have a prismatic joint, right? Yes. What else, guys? We have a sixth link. Also we have a first link. Between the first link and sixth link, what kind of motion we have here? Sliding motion. It means we have a prismatic joint over there. I guess that's all, guys. We calculated every link and every joint. So we got the 6 for the links. What about the joints? 1R, 2R, 3rd R, and 4th R. These are prismatic joints. So we have 4 R joints, and how many P joints do I have? One over here, second one is over there, and third one is over there. So I have 3 prismatic joints totally. So our joint number is totally 7, right? I just wrote down over there 7. We have -1 again. So we said we are going to use 1 for R joints. Also we are going to use 1 for P joints. So 4 times 1 plus 3 times 1. Let me separate this side. Right? This is P prismatic joints. This is for the revolute joints. So over here -2 times 3, we got the -6 plus 4 plus 3. So totally we got the 1 for this mechanism. So this mechanism has a 1 for the degree of freedom of this mechanism, guys. So what was the trick parts of this mechanism? We got 2 different joints at the same point. And also we have another prismatic joints which sliding on in this channel, right? So it's kind of difficult to see this link which is the sliding on this channel, but if you will solve the examples really a lot, and you will use to see the mechanisms, so it will help you. So just try to solve the different examples after this video, guys. Also this one was the sliding on this channel, but it was obvious, you can realize it. So that's all, guys. It was not really hard. So let's keep pushing. We have one more example. Let me change my paper. All right, here. So as you can see, there is a rigid body which is sliding on the ground, and we have a welded point over here. So these 2 gears are connected to each other, and you will see different thing, and I will teach you that. Also we have one more trick part for this example. So let's start it. Now the question is, let's hold this paper like this. Okay, now everything is clear. So the problem is degree of freedom of these mechanisms, and what was the formula? Lambda times L minus J minus 1 plus from 1 to 2 joints total Fi, right? So lambda is 3 for 2-dimensional. So now time to find the number of links and number of joints. as usual, oh, this is also ground, guys. So I'm gonna start with the ground again. I'm gonna write down 1 for the grounds. So now let's start with this point, guys. We have another rigid body over there, so I should write down over there 2. This is our second link. So between the first link and second link, what kind of motion we have between the second and first link? Second link is sliding on the ground, so there is P joint, right? Yes. All right. So another link is starting over here and it's keep going to this point. No, it's keep going to this point, but also it's welded to this gear. So this whole link with the gear are the third link, guys. Don't forget it. So another link is starting over there, which is the center of this gear, and it's keep going to till this point. So this is our fourth link, guys. So we have another gear over here, and this is also a rigid body. So you should write down there 5. I mean, this gear is our fifth link. So you can ask to me why we didn't write down here any number for this gear. Because, guys, as I said, this link is welded to this gear. So this gear is stick to this link. So I already counted that gear as a third link. This gear is also third link. This stick is also third link. These are together. Stick to each other. Alright? Okay. So guys, we said there's a P joint between the first link and second link. So I have here R joint between the second link and third link, right? So between the third link and fourth link, again I have here R joint, right? So guys, this is the trick part. Between the fourth link and first link, we have R joint, right? Okay, everything is clear right now. Do I have another joint over here? Yes, we have, guys. So we have a fifth link. Where is this link? Where is this rigid body? Is it staying on the air? No, it should be connected to somewhere. So our fifth link is connected to somewhere. Where is that? Our center is here, so it's connected to here. So we have also another R joint which is connecting the first link and fifth link. So this R joint is connecting between the first link and fourth link. Other one is connecting between the first link and fifth link. Alright, so we have two same joints at the same point, right? Two same joints at the same point. We got here two different joints at the same point. It could be happen, guys, and you should think that. Probably your teacher could ask you like these examples. Alright, so let's find out our solution. So we got the 5 links, and we got the 1R, 2R, 3R, 4R, and 1P. So 4R and 1P, totally we have 5 joints, right? And minus 1, right? 1, 2, 3, 4, 5. Okay, I think that's true. Plus total. Oh, okay. Let me write down here over here. So 1 for R, 1 for P. 4 times 1 and 1 times 1. So we got minus 3 plus 4 plus 1, and we got 5. Oh, sorry, 5 minus 3, and we got 2 for this mechanism. So let me check one more time. 1, 2, 3, 4, 5. Yes, 2R, 1 more R. No, guys. We have See, this is the another trick point. We have another joint between this gear and this gear. We call that here gear pair, right? This is the another trick part, guys. So between between this gear and this gear, you have to be a gear pair, guys, if they are connected to each other. So let's calculate it again. 3 times 5 minus, we got one more joint, so this is the 6 minus 1, plus 4 times 1 for our joint, 1 times 1 for the P joint, and 1 gear pair times 2. Don't forget it, we are gonna use 2 for the gear pairs. Alright? So if you will calculate minus 2 times 3, you got minus 6, plus 4, plus 1, and plus 2. What did you get? You got the 1. Right? Yes, sir. So our degree of freedom is 1 for this example. So as you can see, guys, generally we are finding the 1 or 2, or maybe you can find the 3 for the degree of freedoms. But if you will find like minus 1, minus 2, or minus 3, or whatever it is, it means your mechanism is not working, or you are doing some math wrongs. So 1 is okay, 2 is okay, and 3 maybe sometimes you can find, it's possible. But also if you will find like 4, 5, 6, it means, guys, you should do your calculations again. It has a really high possibility to being wrong solution. So 1, 2, or sometimes 3 is okay for the degree of freedom of the mechanisms. So it was our last example. I hope that this video will really helpful for your exams. So we just understood how to find the degree of freedoms, and in the next video we will start to analyze the displacement. Also we will analyze after that velocity, and then end of this class we will analyze the acceleration. So it was all, guys. Just be safe over there.